So it's a U sub problem. We know it's a U sub problem because U sub problems look scary. Also, you're going to know it's a U sub problem because I'm still going to tell you. I'll be like, hey, you got to use U sub. We're not going to get to the point where I'm going to mix them together and you have to figure it out. Okay? U substitution is necessary on certain problems. It doesn't work on all problems. It's one of multiple techniques for integration. All of the techniques that we do with integration by hand are absolutely covered with technology. And so in an applied context, if somebody is actually using an integral to calculate something, they're probably not doing the integral by hand. Just like if I need to multiply stuff, I'm usually not multiplying by hand. I'm typing in a calculator. So it's good to learn the theoretical, the actual sort of work behind all the integrals and different calculus to some level, but in an applied class, we don't need to go as deep on that because we are applying it in the long run. So, U substitution though, hopefully from what we've been talking about, the idea is to rewrite the problem as U to a power times du. That's our goal. And the thing that's being raised to a power is typically our u, any quantity that's being raised to a power. So when I see 9 minus x squared all under a root, my mind tells me 9 minus x squared to the 1/2. So the 9 minus x squared is my u. du is just taking the derivative of that u we picked. So I'm looking at that and I'm like, okay, derivative, thinking derivative work, 0 minus 2x, or negative 2x, and extra little fun stuff, we put the dx when we're doing a u substitution. So those are our first two steps in a generic u substitution problem: finding u, finding du, and then making the substitutions. So I'm going to make a little note here. I always say, I want this. I want negative 2x dx in my problem. I want to be able to find that combination of stuff in my problem, because if I can find that combination, I'm going to pull that out and stick a du in its place. And so when I look up into my problem, I'm kind of there. It's okay to not be perfect as long as the only thing missing is a constant factor. So I've got x, I've got dx, dx. I need negative 2 to finish this. And I'm going to make sure we understand that's a negative 2 factor. It's not a minus 2. But, big but, extra numbers change the problem. We're not really allowed to change the problem. So if I multiply by negative 2, I'm going to also multiply by negative 2's reciprocal, because that way that's just a big fancy 1. Multiplying by a big 1 doesn't change anything. Everything's good. So negative 2 and negative 1/2. And I'm going to be about ready to change this problem. The negative 1/2 is going to go out front. Okay. Maybe I'll do like a little check over that. The x dx negative 2 is going to become du. And 9 minus x squared under the root is going to be u under the root. It feels like a magic trick because you're like, ta-da, I have a new problem. But despite all the ta-da about it, it is a mathematically legal substitution. It's a representation of the problem in using this magic U letter, because if we can do that, it makes the antiderivative super easy. U to a power is really easy to take the antiderivative of. So U to a power, I had all the extra pieces just about perfect to make the du show up as well, and I need that as part of the problem. -2 factor, extra thing I needed. -1/2 factor to offset that. The -1/2 factor I throw on the outside. And the only thing left, and this was the new part, are the 0 and the 3. I have an x equal to a 3 at the top, and I have an x equal to the 0 at the bottom of my integral. U is equal to 9 minus x squared. So if I do 9 minus 3 squared, that makes 0. So at the top of my integral, I'm going to have a 0. 9 minus 0 squared is how 0 for x is going to turn into u, which makes a 9. And there's my new problem. That was the newest part last time. The fact that we had to, after we did all that u substitution nonsense, also change the limits of integration, change the shoes to match the outfit. U numbers on, bless you, for A and B instead of X numbers. Using this. Change AB from, that's me, I'm thinking what I want to say, from X's to U's. Now, as much as we're like, are we done? No. But the rest of the problem is fundamental theorem, which we kind of can do. Fundamental theorem means just find big F, find the antiderivative, plug in A, plug in B, subtract. Now, it's big F of U, not big F of X, and so I am writing the of in there because we're not going to, between this and then when we do the integral of E, we're going to have all kinds of dirty stuff in our notes today. F of U, the antiderivative, will be -1/2 u to the 3/2 divided by 3/2. So -1/2 times 2/3 u to the 3/2, -1/3 u to the 3/2. Now, normally in an antiderivative u sub problem, a generic one, we would now flip back to x's and put our plus c in there and we'd be done. We're going to stay in terms of u for this kind of problem. When we're doing a fundamental theorem problem, we're going to stay in u. We're going to use our u numbers. We're going to do f of 0, which is 1/3 times 0 to the 3/2, which is 0. F of 9, which is 1/3, 9 to the 3/2. Oh, -1/3. Sorry. Forgot that negative. So -1/3, 0 to the 3/2. -1/3, 9 to the 3/2 is -9. And then 0 minus -9. All things said and done, because we do f of b minus f of a. 0 minus -9. Final answer is -9. They're time consuming. They're labor intensive. They have lots of steps. We do the u sub, we change all the u stuff, we change the shoes, then we do the antiderivative, then we plug stuff into it, and we do the arithmetic, and then we subtract, There's a lot of steps. Okay. That's why I made the homework assignment a little shorter. I was like, ugh, I don't want to do all these, you know. That's always my thing. I'm like, if I don't even want to do all them, why are they going to want it? So I think, okay, but back it down a little bit. We took 3 of the problems off. You had 5 of them to do. This is one of them. So now you've got 4 of them left to do. Okay. When we do take our quiz on Thursday, you'll have at least one of these. We're kind of talking yesterday in 7th period about setting the quiz up where you have like some choices and it's like, here's the one group of pick one out of this group, pick one out of this group, pick one out of this group. I might do that. It's kind of it's going to be annoying to grade, but that might make you feel a little better, that you feel like you have some control over picking one that looks less scary than another. So, but definitely somewhere in that quiz, you'll have to do one of these. Now, when I grade one of these, I'm going to look at lots of pieces. It's not just all or nothing. It's like, okay, how did you do your U sub? Did you rewrite it? Did you change the shoes, the A and the B? Then how did you do your antiderivative? And then what did you do with the antiderivative and the numbers? Did you look like you were kind of do this? And then finally, did you get to the final answer? So if you missed class last time, you missed us practicing that over a few problems. Those are written out in the notes from last class. You can consult those. The steps for working out the homework problems is all posted on my key. I'm a little tight on after school time next week. I'm not after school Monday, but I will be after school Tuesday for a little bit. And I don't know about Wednesday, maybe Wednesday for a little bit, quiz on Thursday, but you should be able to move. We have 3rd period movement on Monday. So between 3rd period Monday, class Tuesday, which we're going to do nothing but review, and then after school Tuesday, hopefully that'll get you feeling decent for Thursday's quiz. Okay. All right, stop this because that's long.